Welcome to our class. I'm Mr. David Waweru, and I'm going to present to you the computer network models, whereby we're going to discuss the network architecture. Before we discuss what is network architecture, we're going first to understand the communication subsystem. And when you're talking about the communication subsystem, we are saying it's a complex piece of hardware and software. The early attempts for implementing the software for such subsystems were based on a single, complex, and structured program with many interacting components. And the resultant software was very difficult to test and to modify. And to overcome such problems, the ISO has developed a layered approach. And in this layered approach, the networking concept is now going to be divided into several layers, and each layer is assigned a particular task that it's supposed to perform. So the layered architecture is divided in a way that the design is into small pieces, and each piece is able to perform its own particular task. And we have different layers, and the lower layers adds their services to the higher layer to provide a full set of services so that they can manage communication and they run the applications. And the layered architecture also provides the modularity and clear interfaces, meaning that it provides the interaction between the subsystems. And it ensures the independence between the layers by providing the services from the lower to the higher layer without defining how the services are implemented. Therefore, any modification in a layer will not affect the other layers. The number of layers, the functions, the contents of each layer will vary from network to network. However, the purpose of each layer is to provide the service from lower to a higher layer and hiding the details from the layers of how the services are implemented. We have some of the basic elements of a layered architecture, and one of the basic elements is service. And service is a set of actions that a layer provides to the higher layer. Then we have the protocol, and the protocol defines a set of rules that a layer uses to exchange the information with peer entity. And these rules mainly concern about both the contents and order of the messages used. Then we have the interface, and it's a way through which the message is transferred from one layer to another layer. Why do we require the layered architecture? One of the main reasons why we require a layered architecture is the divide and conquer approach, whereby when we divide and conquer, we make a design process in such a way that the unmanageable tasks are divided into small and manageable tasks. In short, we can say that this approach reduces the complexity of the design. Then we have modularity, and the layered architecture is more modular, and therefore we are saying that with modularity, it provides the independence of layers, which is easier to understand and to implement. Then we have the ease to modify, and it ensures that the independence of layers so that the implementation in one layer can be changed without affecting the other layers. Then we have the ease to test, and each layer of the layered architecture can be analyzed and tested individually. The OSI model. OSI stands for the Open System Interconnection, and it's a reference model that describes how information from a software application in one computer moves through a physical medium to the software application in another computer. The OSI consists of 7 layers, and each layer performs a particular network function. The OSI model was developed by the International Organization for Standardization, ISO, in 1984, and it is now considered as an architectural model for the intercomputer communications. The OSI model divides the whole task into 7 smaller and manageable tasks, and each layer is assigned a particular task. Each layer is self-contained, so That task assigned to each layer can be performed independently. Which are some of the characteristics of the OSI model? We find that with the OSI model, we have the top 4 layers which are under the responsibility of the host, where the 3 bottom layers are under the responsibility of the network. The functions of the OSI layers, we see that the 7 OSI layers, and we have each layer with different functions. And the layers are as follows. We have the physical layer, we have the data link layer, we have the network layer, we have the transport layer, the session layer, presentation layer, and the application layer. So when you're talking about the application layer, this layer generally provides the services to the user. The presentation layer, it is responsible for the translation, the compressions, and the encryption of the data. The session layer is used to establish, to manage, and to terminate the sessions. The transport layer provides the reliable message delivery from process to process. The network is responsible for moving the packets from source to the destination. The data link layer is used for error-free transfer of data frames, where the physical layer provides a physical medium through which bits are transmitted. So when we move deeper for each layer, we can see that the application layer is responsible for providing that interface to the application user, and this layer encompasses protocols which directly interact with the user. The presentation layer defines how data in the native format of remote host should be presented in the native format of the host. The session layer is the layer that maintains the session between the remote host, and for example, once the user or the password authentication is done, the remote host maintains this session for a while and does not ask for authentication again in that time span. The transport layer is the layer that is responsible for the end-to-end delivery between the host. The network layer is the responsible for address assignment and uniquely addressing the hosts in a network. The data link layer is the layer that is responsible for reading and writing data from and onto the line. The link errors are detected at this layer. We have the physical layer, and this layer defines the hardware, cabling, wiring, power output, and pass rates, among others. So as we have seen that we have the OSI reference model, and at our next lesson, we are going to discuss the TCP/IP model. And the TCP/IP, TCP stands for the Transmission Control Protocol, and the IP stands for the Internet Protocol. Thank you so much, and I hope you'll join me in the next lesson. And please, you can send any question if you have in the message below.